Now, one of the things that's going to be special when you're going to be counting and finding the probability of events involving the word or is whether or not those events are mutually exclusive. So mutually exclusive events have no common outcomes. So it's impossible for both events to occur simultaneously. So, like for instance, if one happens, then the other one could not possibly happen. So if that's the case, we consider those events to be mutually exclusive. They don't have any common elements. So let's maybe see this in action. So let's compute the probability that the sum is greater than 10 or less than 3. And we're going to do this in this using this table up here. Okay, so that way we can maybe see this table and see this prompt. I'm going to zoom out here a little bit. Alright, bring this down. Alright, so because this one involves the word or, if the sum is greater than 10, I want to count it and then count the associated frequencies to build my, my probability. Or if the sum is less than 3, I want to count it as well. Now, because this involves the word or, what this formula right here is kind of telling me is I could set this up by finding the probability that the sum is greater than 10. I could then separately find the probability that the sum is less than 3. And then I can subtract off the probability that the sum is greater than 10 and that the sum is less than 3. Okay, so let's kind of go through each one of these separately. So let's say I just wanted you to find the probability that the sum was greater than 10. Well, then sum's greater than 10, that would be, the sum would be either 11 or the sum would be 12. So the sum of 11 occurred 2 times, the sum of 12 occurred 2 times. So the probability that the sum was greater than 10, there are 4 outcomes that satisfy, or there's 4 times the experiment satisfied that criteria out of the 50 trials of the experiment. Now for the other situation, the sum being less than 3. So if I want the sum being less than 3, that must mean that the sum is 2. Right? It's the only one of the possible sums I could get that satisfy being less than 3. The sum of 2 occurred with frequency of 1. So that probability would mean it occurred 1 time out of the 50 possible trials. Right, so then that builds that probability. Now for this last probability, out of the 50 possible trials, I want to count any sums that will simultaneously greater than 10 and sums that were less than 3. I want to count the frequency of how many times that happened. Well, the sums that are greater than 10 are 11 and 12. The sums that are less than 3 is just the 2. These two things can't occur simultaneously. I can't have a sum that satisfies this criteria and simultaneously satisfies that criteria, right? That can't happen. So how many times were both of these satisfied simultaneously? 0. These two events are considered to be mutually exclusive, right? Getting a sum of greater than 10 and getting a sum less than 3, they are mutually exclusive. If we look at the outcomes that satisfy this first one, they would be these outcomes. If we look at the outcomes that satisfy this second event, it would be these outcomes. Notice that there are no common outcomes. Okay, so that's the definition of mutually exclusive. The key thing here is if you can recognize that outcomes are mutually exclusive, you don't ever have to worry about this overlap. There isn't any. There will be nobody that shares both outcomes simultaneously. So you can just find these first 2 probabilities and then add them up. So this final probability then would be 5 out of 50, or simplified to 1/10. Okay, so let's take a look at a different scenario just to kind of compare these two. So for this one, compute the probability that the sum is greater than 4 or the sum is less than 8. Alright, so the sum being greater than 4, so that must mean that the sum would be 5, 6, 7, 8, 9, 10, 11, or 12. If I get any of those sums, that satisfies being greater than 4, and then I want to count it. So let's maybe just find the probability of that. The sum is greater than 4. And then separately, we'll worry about this second one being the sum being less than 8. And we'll try to pull all this together. Okay, so we're just going to kind of break this down a little bit. So the sum being greater than 4. So if we come up here, the sum of 5 occurred 4 times, the sum of 6 occurred 10 times, and so on. So I want to just add all of these numbers down here. So 4 plus 10 plus 12 plus 8 plus 4 plus 4 plus 2 plus 2. Adding all of those up, that gives me 46 outcomes that had a sum of greater than 4 out of the 50 trials of the experiment. Alright, so now let's look at the second event that if that happened, I also want to count it as well, the sum being less than 8. So what sums up here are less than 8? So it could be 7, 6, 5, 4, 3, 2, and then there is no 1, so we don't have to worry about that. Alright, so if I got any of these sums, they satisfy being a sum of less than 8, so I want to count it. So, for the probability that the sum is less than 8, out of the 50 trials of the experiment, I got a sum of 8. Let's see, 12 plus 10 plus 4 plus 3 plus 0 plus 1. Adding all of those guys up, that'll get me 30 outcomes out of the 50 total. Now, at this point in time, you might see, just the way we did this, we're double counting some guys, right? There was somebody that was counted in both that numerator and that numerator. Specifically, who did we count twice? Well, we counted twice any sum that was greater than 4, and if the sum was also less than 8. We double counted those guys. So maybe just coming into here, who is in both of these lists? So it looks like the 7's in both of them, the 6 is in both of them, and the 5 is in both of them. So these two outcomes right here are not mutually exclusive. There are some shared outcomes. There are some of these criteria that satisfy both of these. So we just have to make sure we don't double count those. And that's what this last probability is going to be assisting us with. So we just want to count anybody who satisfied both of them, which would be the sums of 5, 6, and 7. So the sums of 5, 6, and 7, we would want to add those guys together. So 4 plus 10 plus 12. So that's going to be 26 outcomes satisfied both of them out of the 50 trials of the experiment. We want to subtract that off. Those are the guys that we double counted in these numerators. So going ahead through then and adding all of these numerators, since I already have common denominators. 46 plus 30 minus 26, that's going to give us 50. So then I get 50 outcomes, or 50 trials that satisfy this out of 50 trials total. Hey, that simplifies to 1. This ends up being actually a certain event for this particular case. The probability of getting a sum greater than 4 or a sum less than 8. Let's take a look at why we ended up getting a probability of 1. You might actually have been able to recognize that that was going to be our probability without sitting here and doing all this counting. The sum being greater than 4. Alright, so sums being greater than 4, that means then I was going to come through here and I was going to grab all of these guys, right? All of those ones are trials that had, oh, not that one, so we start here, right? All of those guys had a sum being greater than 4, so we were going to count those. The second event that I would want to count is the sums that were less than 8. So if any sum that was less than 8, I would want to count that as well. So sums that are less than 8, that was going to go down this way. Well, between these two, I ended up counting everybody, right? So it was a certain thing that I was going to get one of these sums being either greater than 4 or being less than 8. So this ends up, for this particular case, being a certain event. We got a probability of 1.